Hi everyone! Welcome to this week's math video. Today we're going to be learning all about decimals. We're going to learn how to read, write, and represent decimals. We're going to be talking about how to round decimals, and then also we're going to look at different models that you could represent with decimals or fractions. Did you know that, like chameleons, fractions can change into decimals? Right before your eyes. So what I would like you to do is make sure you have a calculator. Someplace in your house there is probably a calculator. Go ahead and find a calculator and then press submit and continue when you have one. Okay, I'm going to show you how you can transform a fraction into a decimal right before your eyes. Let's look at our first fraction, 1/4. Now if you look at your calculator, you can go ahead and press 1 divided by 4 equals, and then tell me what you see in the window. I see 0.25. It turned into a decimal by division. So remember, fractions are simply a division statement. 1 divided by 4. And when you actually do that, it transforms right before your eyes into a decimal. Let's look at our next example, 1/10. So 1 divided by 10. 1 divided by 10 equals, what is in your window? My window says 0.1. Okay, that changed it into a decimal. Let's look at our next example. 1/100, or 1/100th. That's the same as saying 1 divided by 100. 1 divided by 100 equals, what does your window say? Mine says 0.01. Okay, so we can transform fractions into decimals, and there's a lot of good reasons to do that. Now, we've learned that fractions are a way to represent part of a whole. So if you don't have a full pizza, you're going to say, I have 1/2 pizza. Or if you have just part of a candy bar, you're going to say, I only have 1/4 of a candy bar left. And sometimes when you're talking about parts of things, it's more appropriate to use a decimal. And the perfect example that I can think of is when you're talking about money. You would never say or write that you have 1 1/4 dollar. You would use that decimal and you would say $1.25. So sometimes you're going to want to use fractions to talk about parts, and sometimes you're going to want to use decimals. But they are related and they represent the same thing. Let's take a look. So we've already looked at parts as fractions, and we have seen them as models. And then a lot of times what we have been asking you to do is comparing fractions to see which one is bigger or smaller, or if they're equivalent, right? If they're equal. So let's take a look at these three. You can see the digits are all different, right? But you can also tell by looking at the models that they're equivalent fractions. I think you would agree with that, right? So let's squish them together. So here's 1/2, 2/4, 6/12. It represents the same shape, but it's just cut into different pieces, right? Okay, so I would think we all agree that these are equivalent, but you want to know something really cool? If you do that division and change it into a decimal, then you know for sure if a fraction is larger, smaller, or equivalent than another fraction. Let's take a look at these three. So our first example is 1/2, and if you have your calculator right in front of you, you can do this along with me. 1 divided by 2 equals, there we go, 0.5, right? Okay, let's do the next one. 2/4. Click 2 divided by 4 equals, oh my goodness, look at that, 0.5. Okay, let's look at our third one, 6/12. 6 divided by 12 equals 0.5. Wow, so you can see by using division and changing fractions into decimals, you can quickly see that these three fractions are equivalent because they have the exact same decimal value. That is really helpful when comparing fractions, so don't forget that. We're going to go into comparing decimals a little bit later in our next video. So for now, let's go ahead and take a look at how we can read and write decimals. So if you remember, this is our place value chart that we have learned about at the beginning of the year. These are all the place values that you should know in 4th grade, all the way through the millions, okay? We have the ones, tens, hundreds, thousands, 10,000, 100,000, all the way through. Okay, so then where do decimals fit on this? Well, we're going to go on the other side of the ones, and that's where they're going to belong. So we have a decimal, and then we start with tenths. There's no oneths, probably because that's really hard to say. It starts with tenths, hundredths, and thousandths. Okay, and then the differences between these words are that little th at the end. Okay, so you can see it's going to be the same words, but just has a th at the end. And so let's look at the pattern here. So we have our ones and the decimal kind of in the middle. And then on both sides are the tens and tenths. And then if you go over one more spot, you have the hundred and the hundredths. Then if you go over one more spot, you have the thousand and the thousandths. So it's kind of like a mirror image. Okay, so those are the place values that I really want you to know. Okay, so let's take a look at our first problem that I want you to try to solve all by yourself. What digit is in the tenths place in this number showing? What digit is in the hundredths place in this number? And then what digit is in the thousandths place in this number? Okay, so let's go ahead and talk about how to read these decimals. So when you have a decimal, a lot of times students and sometimes adults, we don't say it correctly. There's kind of slang way to say it, and that's what I used at the beginning of the video. So if I were to see this number, a lot of times adults just say 34.1, and that's okay. That's how we say it when we're adults, 34.1. But there's actually a more correct way to read this. Okay, so we're going to learn how to do that. So first we're going to put this digit on our place value chart. Here we go. We got it now. So you just got to line up that decimal. And now what you do is you read it as 34 and 1/10. Okay, that's the proper way to read it. Okay, so what you do is you look at the number before the decimal and you just read it like it is, 34. And then when you say the decimal, you're going to say and. 34 and. Then you're going to look at the number on the other side of the decimal and you just simply say what it is. This time it's 1. And then the very last word you're going to say is the place value that 1 lands on. Tenths. Okay? So again, this is 34 and 1/10. All right, let's try another one. Okay, so you might quickly say 1.89. Well, if you see it written as words, it's not going to say point, and it's not going to say 89. So let's remember how to properly read this. Let's put it on our chart there. We're going to read 1 89/100ths. Okay, so first you take a look at the number in front of the decimal, 1. Then you say the decimal, and then you take a look at the number after the decimal, 89, right? That's 89. That's easy. And then you look at the very last place value that's showing, hundredths, and you say that. Okay? So this would be 1 89/100ths. All right, so now let's look at another example. This one is a little bit different and kind of a little bit easier. You see here we have a 0 instead of a digit here in front of the decimal, and that's just to let everybody know that no, we didn't make a mistake and forget to write it. We know there are no whole numbers. It's just part of 1. No whole numbers, just the part. And so the way that you would read this one is much simpler. You don't have to say what comes before the decimal. You don't have to say the decimal. You only have to say what comes after the decimal. 624 thousandths. And that might look kind of big and scary, but really all that we're doing is like looking at the number that comes after the decimal. Look at that, 624. That's not scary. 624. And then you say the very last place value that digit is in. Look at that 4. It's in the thousandths place. So that's the word you use at the end. Okay? So this one would be 624 thousandths. Okay, now it's going to be your turn. How is this digit written with words? Take a look at your options and tell me what you think. Okay, now we're going to do the opposite. Now I'm giving you the words, and we have to write them as numbers. Okay? So 2/10. Okay. What do I do? Well, I want you to do one thing when you're writing decimals. I want you to first somehow underline or circle or put a square around the place value that they talk about. Okay? We're going to look at that later. First, we're going to focus on the other part. Okay, so it just has a 2. Now, I know the only digit that I'm going to put on my place value chart is the number 2, but where do I put it? Since there's only one digit, I'm going to put it in the tenths column. Okay, and that's going to look just like that. And we are already finished. 2/10. Okay, so let's try the next example. This one says 200ths. So what does that look like? Well, somehow put a circle or something around your place value that they show you, because we're going to look at that last. Now we're going to look at the number that they're giving us. It's 2 again, but this time we have to put that 2 in the hundredths place. Okay, so let's put that in the hundredths place. But wait a second, that can't be all we do because that looks just like 2/10. But it says 2/100. So we're missing one important thing. Do you know what we're missing? We're missing that placeholder of a 0. That 0 is extremely important because that changes it from 2/10 to 2/100, which is much smaller. So that 0 is very important. Okay, so let's look at another example. This says 17/100. So where do I put it? Okay, first of all, indicate what place value it is. We're going to look at that last. Okay, so 17. I'm just going to write the digit 17. But where do I put it? I'm going to put it on this chart in a way that the last number lands in the hundredth place. Just like that. 17/100. 17/100. Okay. Now let's look at another example here. 17,000ths. Where would I put these digits? Well, take a look. We're going to put a square around our place value. Take a look at our digit. Okay, it's 17 again. And we're going to put it on our chart in a way that that last digit falls in the thousandths place. 17. But I can't stop there. I need that important placeholder right there. And that would represent 17 thousandths. Okay? All right. So now I'm going to let you have a turn. Which of these 4 numbers is 405 thousandths? What do you think? Okay, let's move on now to how to represent fractions and decimals with a model. We've done this a lot with fractions. So we're going to look at that first and then see what it looks like when we're making decimals. So I think everybody would agree that what you see in front of you is a 1 orange square, right? It's just 1 square. It's all the way there. If you want to pretend it's a cracker, it's completely whole, 1 whole cracker, okay? And then I'm going to cut it into 10 pieces, but it is still 1 cracker. It's all there. None of it's missing. So then if you start to actually give part of your cracker away and you have just a part of it left, that's when we're going to start using our fractions or our decimals, because that's how you talk about parts of a whole. So if I just had this 1 part left, and I can see that it's cut into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces, and I have 1 piece left, I think you would agree that you would write that 1/10, correct? Okay, if I got crazy and I thought I want really, really tiny pieces, and I cut that cracker into 100 pieces, then the number on the bottom is 100, correct? And then that same exact spot that we had before now becomes a 10 because it's cut into 10 pieces. But if we look back at our other picture, let's go back and forth. You can see it's representing the same exact part of the cracker. So since we know that 10/100 equals 1/10, right? And you could see that too, because you could cut this 0 off and this 0 off. And that's one way that you can reduce fractions. And you would be left with 1/10. Okay, so now let's look at these words. 1/10, that's how you would write it. And this is 1/10, that's how you would write it. It's exactly the same. You would say it exactly the same. And so it's true that you would actually model it the same. 1/10. Okay, because that means there's 10 pieces here and only one of the 10s is showing, and so you would represent that 1/10. Okay? And then if the same thing was true, you cut that cracker into 100 pieces, and then now this section has 10 pieces, so this would be 10 1/100ths. So then as a decimal, it would look like this. 10 out of the 100 pieces are colored orange. And so then you can see, if you look at both of these, it represents the same part of the cracker, right? So we can clearly say that 10 hundredths is really the same thing as 1/10. And that's why when you're writing decimals, if you have a 0 at the end, a lot of times you can just not include that. You could delete that off because it represents the same exact thing. All right, so how would you represent this digit on a grid? Just like in the model that we just used, how would you represent this number? So let's first put it on our place value chart so we can look at what it is. It's 1/100ths. So what would that look like on a chart like this? 1/100ths looks like this. 1/100th, 1/100th. Can you imagine what this was going to look like? Yep, there you go. Just one of them is colored in. So that is a decimal model for 1/100th. Okay, so let's take a look at another one. If I showed you this model and it had this portion colored in, how would you write that as a fraction? And how would you write that as a decimal? There's 100 total pieces, and this is 2 rows of 10, so this is 20. So our fraction would be 20 hundredths. And our decimal would be 20 hundredths. See how that the 0 is in the hundredths place? So you would read this 20 hundredths. So that means that 20 of the 100 are colored in. What about this one? How would you write this as a fraction? And how would you write this as a decimal? This is 2 rows of 10, so 20, and then 1, 2, 3. So as a fraction, it would look like this, 23 hundredths. As a decimal, 23 hundredths. All right. I think you guys are getting the hang of it now. What if you had a model that looked like this? How would you write that as a fraction? How would you write that as a decimal? Well, this is 1, 2, 3, 4, 5, 6, 7 rows of 10. And then 1, 2, 3, 4, 5, 6, 7. Okay, so that is 77 out of 100. 77 hundredths. So then if you wrote that as a decimal, 77 hundredths. Very good. All right, so now here's a challenge for you. Here's a model. Look at this one. We have one full cracker and part of another. How would you write that as a fraction? We have one whole and then 40 hundredths. Okay. And then you could also write that as a decimal because we have one whole and 40 hundredths. 1 and 40 hundredths. Now if you wanted to simplify that, you could just imagine that these were cut into smaller pieces and not, it's the same thing, but just not cut into 100 pieces, but instead just 10. It would be 1 and 4/10 or 1 and 4/10. Either way, all right. So I'm going to let you try this one. Let me fix this for you. So if this model at the top is how you would represent one whole, they're always going to let you know how one whole is represented. So if it's all filled in, it's 1. Well, now let's look at this model. This is shaded to represent part of 1. So what decimal down here best represents this shaded portion, the part that's gray? Okay, we're going to jump right into rounding decimals, and we don't have to spend a lot of time on this because in video number 2, we talked about rounding. So it's the same exact process. The only difference is knowing the 3 extra place values. So let's look at our first digit that we're going to do together. 3 and 537 thousandths. First, we're going to round to the nearest whole number. Well, what does that mean? Well, we know that any number that's on this side of the decimal is whole. Any number that's on this side of the decimal is just the part of a whole. So they want us to round to the very first whole number. That's the nearest whole number. So we're going to round to that place value. Okay, so here's our number. Remember our poem from math video number 2? Find your number. That's the place value that we're rounding to, the nearest whole number. Look right next door. 5 or higher, add 1 more. 4 or lower, just ignore. So we're going to add 1 to the 3, and then everything to the right is going to become a 0. Now, since those zeros are not placeholders, there's no other digits, we actually can just write 4. Okay. Now let's look at the next one. Round this one to the nearest 10th. Okay, so find your number. That's probably the most important part because you have to know these place values. Find your number. There's the 10ths place. We're going to look right next door. 5 or higher, add 1 more. 4 or lower, just ignore. So that 3 is lower than 4. So we're going to ignore that 5 and keep it the same. Turn everything else to 0. And it would look like this. And again, the zeros at the end don't really do anything, so you could just simply write 3 and 5/10. Okay, last one, round to the nearest 100th. Okay, tricky part? Maybe not so tricky for you guys. Find your number. Which digit is in the 100th place? There it is. Find your number. Look right next door. 5 or higher, add 1 more. Okay, 4 or lower, just ignore. Okay, so that 7 tells us to add 1 more to that 3. So we're going to change it to a 4, and then everything else to the right becomes a 0. Okay, and again, since that 0 at the end is not holding a place, we could just ignore it. And our answer would be 3 and 54 hundredths. So now you get to try this one. It says round 5 and 641 thousandths to the nearest whole number. And this is a challenging one. This is a released SOL question. So this is what they like to do. They try to make it a little bit more challenging for you. So it says, which number, when rounded to the nearest hundredth, is equal to 7 and 59 hundredths? So they've given you the answer. Which one of these, when rounded to the hundredth, would equal this? So you kind of do it backwards, which means you need to round all 4 of these to the nearest hundredth and see which one would equal 7 and 59 hundredths. Take some time and work on that. Well, what do you think? Was that challenging? Was that easy? Well, if it was challenging, I know that you guys aren't afraid of challenges, because I know by now you understand that the more you practice, the better you're going to get. So it's okay if you don't understand how to do it yet. You will. Just keep practicing. Believe in yourself, and I know you'll get there. All right, thanks for watching.